Alright, on this video we're going to look at some things that deal with Pythagorean theorem. I know you've seen this before, but there's a couple things that we need to talk about as far as how you're going to use it and a couple of extra things that you have not seen before. Alright, before we get into Pythagorean theorem, you've got a right triangle. Okay, with your right triangle, this side that's opposite of your right angle is always your hypotenuse. Okay, and that's also always your C value. Okay, your two legs are going to be your A and your B. And it doesn't matter which one you make which, as long as you've got an A and a B in there. Okay, and then in case you've forgotten, your Pythagorean theorem is A squared plus, where's my pen not working? Plus B squared equals our C squared. And that's our Pythagorean theorem. Okay. Alright, now with Pythagorean theorem, we're not going to do any just basic examples. You can do just a simple Pythagorean theorem. But what we're going to look at is something a little bit farther. Something called a Pythagorean triple. What a Pythagorean triple is, their values, side lengths of a right triangle that are whole numbers. Okay, and there are 4 of them that I expect you to memorize. Now, you can have multiple other values for the values of the legs of a side of a right triangle, but there are only just a few specific examples where they all happen to be whole numbers. And like I said, these are the basic ones. One I underlined there. Those are the basic ones that you need to know. Now, for example, if I scroll down here, and notice the non-examples here too. I've got this radical 2 in here, radical 45. These are all values, lengths of the sides of a right triangle, but they're not Pythagorean triples because they're not all whole numbers. Now, if I look at a couple of examples here, if we want to decide whether or not these are Pythagorean triples, what we want to do is we want to take those original values that we looked at up here, and we just want to decide, do they fit? So do I multiply any of the sides by 2, 3, 4, or 5 to see if those values work? Well, this 9, 12, 15, if I look at this first one, this 3, 4, 5, if I take that times 3, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. So this is a Pythagorean triple. Okay, so looking at that second one, 14, 48, 50. If you look up there at the very top of the screen, try to decide which one. I'm multiplying one of them by 2, 3, 4, 5. This first one, it's actually a 7, 24, 25. Multiply them all by 2. Okay, on that next one, if I look at it, it's close. It's very close to this one right here, the 5, 12, 13, but it's not exact. It's got 2 of the sides, but not a third side. So this one would be no. If I look at the next one, the 16, 30, 34, it is. It's a yes because it's that one right there. And finally, the 16, 12, 20. Now in this one, I kind of put them in a different order to kind of throw you off a little bit, but if I look at it, it's actually this 3, 4, 5 right here. I just switched the 12 and the 16. Those are still lengths to the sides of my triangle. That would be 3 times 4, 4 times 4, 5 times 4. So yes, this one would be Pythagorean triple also. This is actually the last slide of this video, just real short. We want to decide if we can use Pythagorean theorem to determine if a triangle is acute, obtuse, or right. Okay, and so we've got an example of each. So for this first, we're going to go ahead and do our Pythagorean theorem and see what we get. So I'd have 7 squared plus 10 squared equals 15 squared. Okay, go ahead and multiply that out. So that's going to be 49 plus 100 is 225. Add that 49 and 100, I get 149. Well, if I look at that, they're not equal. So I know it's not a right triangle. My C is bigger. If my C squared is bigger, it's obtuse. Okay? If my C squared is bigger, it's obtuse. So let's look at this next example. So I'd have 4 squared plus 5 squared equals 6 squared. So I'd have 16 plus 25. Oops. 16 plus 25. Let me erase that. That's supposed to be a 5 there. Equals 36. 16 and 25 is 41. That's greater than my c squared, so my c squared is smaller, so that would make it acute. Then finally, if I give you three values, so 6 squared plus 8 squared equals 10 squared. Hopefully, just looking at it, you remember that it is a Pythagorean triple, but just to show you what you're looking for, to prove that it's a right triangle, so I have 36 plus 64 equals 100. That 36 and 64 is 100. They're the same, they're the exact same thing, so it's a right triangle. Okay, so remember that when my c squared is greater, okay, so when it's a squared plus b squared is less than my c squared, it's obtuse. When my a squared plus b squared is greater than my c squared, it's acute. And when it's equal, it's right. Alright, and that's it for Pythagorean theorem. Thank you for watching the video, and we'll finish the assignment in class tomorrow. We'll grade it on Tuesday.